How many of you own an EV, electric vehicle of any nature? Okay, I see good amount of hands. How many of you plan to buy one? Okay, very heartening to see. I've been in this space from 2016-17, working with all the early vehicles, but my space is not making a vehicle. I think we have veterans from TVS who will talk about vehicles. I looked at the energy. See, all of us charge our mobile phone. It's a very, very well-known event. Your phone, all of us carry our phone. We run out of energy very soon. It's a very instinctive act. We all know how to charge our phone. But when you look at an electric vehicle of any of this nature, it's nothing but the same battery, and you need to charge. Yeah, and then that gets interesting because it's not as easy as it is to charge a mobile phone. And even if you look at mobile phones, somewhere in the past, we used to run out of energy in airports, search for a charging port. Then we started carrying battery bank. But you can't do all of that with an electric vehicle. Though we are trying to do almost same. I'll talk about some things where a battery is being carried to charge an electric vehicle on demand. I mean, if exactly like the way we do the mobile phones. Okay, starting with what I wanted to share with all of you. Whenever I talk about EV, it's like 4 or 5 blind men and an elephant. Everybody talks about one part of the ecosystem. Our experience in the last 6-7 years is that it's a multi-industry game. It is not one industry trying to define everything. Of course, everything starts with a vehicle moving from an ICE engine to a motor, battery coming in, the fuel technology changing. That's one part of it. The moment you see that, you have to remember that this vehicle has to be charged by somebody. Electricity has to be given by somebody. And that's our traditional electric utilities who've been there for more than 100 years, but they have never tried to charge so many public vehicles at a time. They've done railways, some things have been done, other kind of vehicles, traction has been done, but never at smaller vehicles, all kinds of moving vehicles. The utility is not yet designed for it, not fully designed for such a load coming in. Then we always might wonder, where are the other industries? It's an IoT device now, vehicle and the charger, both are IoT devices. You need all of them to be connected. If telecom doesn't work, none of the workflows which all these industries are defining works. This was the first learning we had in 2018 when a 4G connection doesn't work. All what we are talking doesn't work on the ground. Somebody is trying to charge and he's saying it doesn't work. After a lot of finding out, debugging, you figure out that it's just the network is not there. He's in a highway, there is no network, nothing worked. So we had to find solutions. What happens when there is no network? But now network is so good enough that we don't worry about it. So telecom industry with 4G, 5G becomes equally important. When all of this is happening, a decade back, I'm quite sure in such a conference, we would have talked about big data, cloud, IoT. These were the buzzwords, keywords we were talking 15 years back, 10 years back. But now we don't talk about it because it's all real, it's there, it's happening. A lot of data is being churned out by vehicle, by charger, by grid. Everybody is churning out a lot of data, and everything to make it work is happening on the cloud. Everything is being churned in the cloud, and only then all what you see actually works seamlessly. So you need a whole host of cloud technology now, edge technologies, how to collect the data, all of that needs to be in place. So all these 4 or 5 industries have to come together to make a very simple event as charging your vehicle at any one point. I think a lot of things have to come together to make it work. Out of this, my area of interest and my business where we have spent quite some time is looking at what I call as an energy value chain. I don't look at the vehicle per se on making a vehicle, but how do I make it very efficient from the point of energy, source of energy, to where it is consumed, that it is effortless, seamless. For an end user, it should be as easy as possible. For the one who's installing and getting into the business, easy to monetize, make money out of it. And for the utility, which is where we get this lighting too, it should not be disrupted because I get a new vehicle onto the grid. Because the more the vehicles, the grid is getting loaded. So how do you manage all of that? That's been something very fascinating. Lot of work happening world over in this just value chain to figure out how it is done. And that's where this talk is all about, energy intelligence in the EV ecosystem, not everything. The first thing we experienced way back 6-7 years back is on the left side you see a typical petrol pump where people go, and right now you can fill your vehicle. There is somebody standing there to fill your vehicle, make you pay using a POS machine, UPI, whatever you use. But when it comes to EV, electric vehicle, whether it's a four-wheeler, two-wheeler, when you are on a highway, it's unmanned. It's there at a restaurant, it's there on the highway. It's now left to you to figure out how to use it. It's very common in other countries. In India, we are never used to doing things on our own. So we had to develop a lot of tech to make it as easy as possible for anybody on the highway, because most people who are charging were fleets, cab drivers, taxi drivers, and they were not very, let's say, fluent with accessing a lot of digital gadgets, HMIs and everything. So that is the first challenge. The first challenge is to see how to make it easy so that the user experience becomes seamless. So somebody can go and just charge and pay the money and not worrying about it. What helped us is that I think we are all very good at digital payments now, and that gave it a very good boost to see digital payments with 5G in place, and also everybody using a mobile phone made it very easy to access energy, get an authorization, get the vehicle charged, pay for it, and then move on. When this is happening, now the requirement came that, oh, I have too many things, I don't want to use my mobile phone. So we started introducing NFC cards or RFID cards, wherein you just go tap on the charger, it starts to charge, you don't worry anything, it auto debits from your either a UPI mandate or from one of your wallets. Then came a requirement saying, oh, I don't want to do this also. We introduced another technology where if it's a car, you just plug into the charger, it automatically talks to the car, finds out which car it is, finds out who you are and starts to charge and makes a bill automatically. Then now the next step is come where we are saying, oh, this is not secure. Anybody can come, anybody can plug in, what do I do? Now we are doing something called plug and charge, where there are certificates being sent on the cloud, everything is authorized by bank, and then the charging happens. So a lot of things just to make it as simple as possible, because that's where the EV adoption happens, because when you are very sure that I can go anywhere and I can charge and I can pay, and as easy it is, people will buy more vehicles. I mean, this is the famed range anxiety problem. Everybody is worried about, oh, can I take my car? Will I have a charger? There are sufficient chargers coming up, but these techs came up. And I think we played a role in bringing a lot of tech in getting all these things working. The next thing we realized in the years is the charging is not done at one place now. Unlike a petrol pump where you have to fuel at a fuel station, here you can charge at anywhere actually. The charger is at your home, charger is at your office, charger is in this hotel, charger is on the highway, charger is in a fleet hub or a hub. Charger can be anywhere. Various kinds of chargers. Now it is not one kind of device and you just go and take energy or a fuel. Here you have an AC charger which is a socket. You have a fast charger which is giving energy at 1 megawatt. So there is plethora of devices which came up at different technology, different rates based on the vehicle. It gets very complicated. Now, it also was an interesting thing for us to see where will actually people charge. Worldwide, 85% of the time, the charging is done at home. When you park your car or vehicle at home is where it gets charged. So should we do any of these? The problem is when these 85% of the cars are on the road, there is always a fear that what happens if my energy runs out? Where do I charge? So equally public charging is coming up, and then you will see chargers everywhere, all around the place, you will see in all places. When all this was happening, there were some interesting things which happened, which is very unique and special to India. People found out ways to use it without paying money. Very interesting thing was all these devices had something called an emergency button. It was introduced because it's all high power electrical equipment. If something goes wrong, you should have an option to press and pull the cable out so that you are safe. But people figured out that by just pressing, you don't have to pay money. Because it was emergency, device shuts down, take as much energy as you want, the gun is unlocked, you go away. We had to build technologies now to ensure that even if you press, you're billed. You take energy at that point and you bill. And that loophole was the first loophole everybody tried to figure out how to get out of it. And next is, of course, which is even more cruder, people figured out that the cable, the copper cable which is there, is far more expensive. So people come, just cut the cable and take the cable away. It's the biggest challenge in many cities right now, because all the fast chargers, the cable is heavy copper, just cut the cable and take it away. That's the reason you will not find a lot of chargers not working, because people have taken the cable away. Now it's no longer tech. We are now trying to find out, should we introduce CCTV, introduce intelligence to find out who's that person capturing, at what instant did he cut. Just makes it very expensive. Hopefully we as a society, we will not get into pulling out the cables, but just let the device be. Yeah, as we did this, also another interesting topic came up saying, why should I charge my vehicle? Why can't it be like LPG cylinders used in the vehicles in Delhi and many, now everywhere it is there? Can I not just swap, replace my battery and move on? It was very easy use case for two-wheelers, three-wheelers, not so much for the cars. Car did not get in. We own a lot of patents in this area. We did the first early systems to say how to charge an auto rickshaw or a two-wheeler, to swap the battery and take it out. It is a very nice thing to do. The problem is not to do with batteries, not to do with here. It's all about business model, where who owns the battery. Will you be interested? I mean, if you own a bike, would you be interested in a nth time used battery in your vehicle? Would you like to have it in your vehicle? People didn't like it. So it is more of a business model problem than a technology problem. But in fleets, logistic fleets, any kind of fleets, it works very well. Retail users or users like us don't want to have it. So I think that is something we figured out in this journey. As we do this, like I said, home charging is important, apartment charging is important. What became a problem in many countries, also in India, is, let's take this building, there are chargers below here. This building is designed to take a particular load from the distribution company, and it is fixed. It is already set, the transformer is set, the substation knows this is the power it takes. Now if I park 10 Porsches or 10 high-end cars below here, they will suddenly need 1 megawatt more energy, because each one is 100 kilowatt battery. All of them plugged in, they will take 1 megawatt at one time. Now the building gets into trouble, lighting gets into trouble. There are countries, like in Singapore, they gave a regulation saying, if I insert an EV, it should not disturb a lift, or nothing should happen to a human life. Because if the power is sucked very badly, the lift may stop working. People might get stuck in a lift. Lighting may go off. So countries started to give regulations to say, you need to protect human life, not about charging. So then a lot of regulations came up and say, do smart charging. Find out what is the available power at that instant. Can you slow down the chargers? Can you slow down the vehicles? So a lot of AI has been built here. Now not to charge, how to slow down. Because if something goes wrong, how do I slow down? So initially we all thought about making it faster and faster and charge faster. Now we are building a lot of tech to make it slower and slower. I mean, have a control on making it slower. I mean, I'm not saying make it slower, make it controllable. Yeah. The same thing then people went one step ahead. My car is an UPS. I've parked at my home. It's a 60 kilowatt battery. Why do I need a home UPS? Why can't I just connect my car and light up my home? It's charged. It's fully there. And I can light up my home, use everything at home. It's 60 kilowatt, not even 2 kilowatt battery you keep at your home. Now it's a 60 kilowatt battery. Now this is called bi-directional charging. You connect to a charger. Now your home can start taking power from the car. It's called vehicle to load. Then we went one step ahead. Then if there are 20 cars in an apartment, it's a power plant now. Because it's 10 kilo, I mean almost 1 megawatt power plant standing in your apartment. Then apartment said, why can't I use that? Then came grid, they went one step ahead. If in an area, if there are 100 cars in an office space parked electric vehicles, it's a huge power generator now, because it has all the power. Can I use in managing my substation? Can I moderate the power? Can I change the harmonics? Can I take the voltage regulation? All that happen, it's happening. This is a new thing which we are all doing, gone up to the grid saying, now it's no longer charging, now we are talking about how do I manage, use all this data. Very few slides, I'll wind up with this. Future, as we are talking, there are a lot of talks to say, can I make it wireless? Remember wireless charging? I'm not a strong believer, because I don't think many of us use a key charging on mobile phone. It looks nice, cool, but after some time you realize that has to be powered up anyway. There has to be a cable. You can as well plug it into your phone. Similarly here on road, can I have something by which car can charge itself? Trials have been done. A lot of tech around it. It will take some time to come. You also have now, let's say, wireless, solar. A lot of work happened and say, can I put solar on the vehicles? Right now it's not, it doesn't generate so much energy for you to use it, but eventually it will come. Pantographs have already been very popular in many cities. Buses can use ultra capacitors, charge very fast, go some distance, then again charge. So that is being done in many cities. And a lot of them are now building megawatt chargers for trucks and buses because you need long distance haul, you need very extreme high power charging to do charging in 5 minutes, 10 minutes for a truck and a bus. So a lot of things happening there. Last question which comes up is, this is the thing I would have started off with, but I wanted to end it with this. Everybody asked me this question when I said I work in EV. Two questions come up. Do you have energy? When I go out of India, people ask me saying, India, there is no electricity. How do you work with EVs? India has power surplus. I think if you read data, you will figure out that India has power surplus. Our distribution might be a challenge, but we are power surplus. Second is very interesting. Last week, government also announced that 50% of our current energy mix is non-fossil fuel. Because everybody asks saying, how clean is your fuel? Why are you burning coal to run an electric vehicle? But now 50% is from renewables. I mean, not only renewable, hydro, solar, wind, all of them are nuclear, non-fossil fuel. So this mix is supposed to change over time. And as we have more solar and renewables, it makes absolute sense to go towards EV because energy is actually quite clean and cheap. Yeah, I think we had an AI talk before this. So two things. There is a lot of question on saying where is AI? Is something doing in EVs? Absolutely. We call it agentic AIs, which is more autonomous, which is doing a lot of things. It starts within the vehicle, in the charging ecosystem. Everywhere you have a lot of work going on to make it super efficient. On the vehicles to make the battery life better, on the charging side to ensure, like I told you, balancing with the grid in real time, how do you work on it, a lot of work going on. Everything has to be automated in real time. Nobody can do things manually here. And also when you get into all the data coming in, a lot of insights have been figured out to find out what to do. Last thing, all these slides are done by a chatbot. Only talking points are mine. I put all my points and I said, generate a slide for me. This is not my slide deck. It was generated by a chatbot. One of the GPTs, and everything was done by just the talking one bullet point is mine. So all you heard about, whatever I told you is my experience, but the slides are from somebody else, not my slides. Thank you.